Now that we understand these trade-offs, we are going to discuss a very clever idea called memory hierarchy, which sort of combines these various technologies together in one system so that we create the illusion of having very fast memory, but large amounts of it as well. This is a very fundamental concept in computing. It's very important for you to understand the ideas behind this video very well. Let me just give you a very high level overview of how memory hierarchy works. In the previous chapter, we learned about the CPU. Inside the CPU, you saw that we have the register file. The registers are the highest level of hierarchy that we have. It's sort of the fastest and a smaller amount of memory that we have. Inside CPU, we are going to also have a different memory. It's usually inside it. Sometimes it's close to it, but not inside it. Depends on the architecture. This kind of memory is going to be implemented with that SRAM technology that I described before most often. It's going to be called cache. Then outside the CPU, we have we have kept saying that in addition to the CPU, we also have the memory. Memory sits outside the CPU in most architectures. Okay, so memory is going to be much bigger than either cache or the register. So, just as an example, the registers in ARM, we said we have 32 registers. So multiplied by each of them were a double word, so 8 bytes, right? So you have only 128 bytes of it. The cache, depending on how many levels you have, it could be from, I don't know, kilobytes to perhaps megabytes. When it gets to megabytes, it's usually sitting outside the CPU, but that's kind of like the range. And when we are talking about the memory, this is like the memory that your machine has, right? So machines these days, let's say 1 to uh, 16 gigabytes of the memory they easily have. And like I said, there are machines with up to 1 terabyte of the memory. And then the next level is just the hard drive, right? The hard drive, of course, they are much slower. And here we are talking about many terabytes, right? We talk about hierarchy because the way these things are designed is that a subset of the data that you have at any level is going to be presented in the higher level. So the right way to think about the cache is that it's also memory, just like the main memory, but it's the part of that memory that we use often or we think we are going to use often. So we take parts of the memory that we think we are going to need a lot, and we are going to save them for ourselves in the cache. So as example, let's say these three parts are saved for us inside the cache, with the idea that these are the parts of the memory that we use often, and so now if we have them in the cache, the CPU can use them quickly without going to the actual physical DRAM memory. Okay, so this is the hierarchy, right? Some of these data are presented there. So the same is true here. Some of the data that we have in cache is going to be also in your registers. So when you load and store, you're really dealing with the cache as we will see. The memory that you have, the physical memory that you have here is limited. So for example, the amount of the memory, like I said, on my machine, for example, is 8 gigabytes, for example. If I open up 100 different apps on my machine, it's going to run out of the physical memory that it has, but it will keep working. How is it that it can keep working after it has run out of physical memory? The answer is something called a virtual memory. And the virtual memory, again, is the same concept applied between memory and the hard drive. So in one part of your hard drive, you are going to assign it. So a lot of your hard drive is just to save your files and things like that. But there is going to be some region in your hard drive that its job is to basically work as a backup to your physical memory. This concept of backing up your physical memory inside hard drive is something that we will learn in the second half of this chapter. Is called uh, a virtual memory. Right. So the first half of this chapter is about the connection between the cache and the memory. The second part is between memory and the hard drive. Is called virtual memory. Your course notes also have a different way of depicting a memory hierarchy as shown here. So what we hope is that the CPU does most of its computations with registers. Then the stuff that are not in the register, we hope that they will be in the cache. The stuff that are not in the cache, we surely hope they are in the memory. Every now and then things are not in the memory there, you have to go to the disk space and look them up. These are some sort of ballparks of the access time for each of these memories, and you can see that their differences are orders of magnitude. And in particular, disk space is extremely slow. When you are trying to do on your something on your machine, and your machine has become all of a sudden extremely slow, and then it goes back to normal, usually what's happening is that your machine is forced to go back to the disk space to do this step. This step is extremely slow. Understanding how this works is going to enable you to improve the speed of the programs that you write.